Hi, I'm Alex. Welcome to this explainer. We hear the word magic thrown around a lot when we talk about the Spring framework. Well, today we're going to pull back the curtain. We're taking a factory tour to see exactly how Spring builds and manages your applications under the hood.
So let's start with the big question. Why even bother with Spring in the first place? Why do so many developers rely on it? Well, it all comes down to taming complexity.
See, without a framework like Spring, every single piece of your application is responsible for creating and finding all the other pieces it needs to talk to. Imagine a car trying to build its own engine, then its own wheels. It just leads to this tangled web of code that's super rigid, tightly coupled, and honestly, a nightmare to test.
To fix this, Spring introduces this really powerful idea called Inversion of Control, or IoC for short. And it does exactly what it sounds like. It completely flips the script. Instead of your objects being in charge of everything, you hand that control, that responsibility, over to the Spring framework.
And this slide just lays it out perfectly. On the left, you've got the manual way, that tangled mess we talked about. But on the right, you have the Spring IoC container acting like a master assembler. It figures out what needs what, builds all the parts, and wires them together for you. The result, a much cleaner, more flexible, and way easier to manage application.
So here's our game plan for the factory tour. We'll start inside the container, see how it makes the blueprints, follow a component down the assembly line, and then see how it all comes together in the end. Sound good? Let's dive in. All right, welcome to the factory floor. The absolute heart of Spring is this IoC container. Its one and only job is to manage the entire life of every object in your application. And in the world of Spring, these objects have a special name. We call them beans.
So this is the key takeaway. Your code doesn't go looking for its dependencies anymore. It just declares them. It says, hey, I need a database service, and the Spring container provides it. That act of providing the dependency, well, that's what we call dependency injection.
Okay, so how does our factory know what to build? It can't just guess, right? It all starts with Spring scanning your project to find the instructions.
This whole process usually kicks off with an annotation you might have seen. @component_scan. Spring then basically goes on a treasure hunt through your code, looking for special markers like @component or @service. But here's the important part. When it finds one, it doesn't build the object right away. First, it creates something called a bean definition.
And you should really think of a bean definition as the architectural blueprint for an object. It's the recipe. It tells Spring everything it needs to know: what class to use, how to build it, what other parts it needs. All the instructions are right there in that blueprint.
Okay, the blueprints are drawn up and ready to go. Now for the exciting part. The bean is heading to the assembly line, where it will actually get built. This is the core Spring Bean Lifecycle in action. Now this assembly line has very specific stations, and the order is crucial. First, Spring just creates a raw, empty instance of the object. Step 2, it populates the properties. This is where it injects all the dependencies. Then it runs any custom setup code you wrote. And only after all of that is the bean considered ready for use. And of course, at the very end of the application's life, there's a final destruction phase for any cleanup.
But this brings up some really interesting questions, doesn't it? I mean, how does that populate properties step with @autowired really work? Is it magic? And what if you, the developer, want to step in and modify the bean while it's being assembled? Well, this leads us to the real magic of Spring, the quality control and customization stations on our assembly line.
The answer to those questions lies with a set of special beans that are kind of like our factory's expert technicians. They're called BeanPostProcessors, and they're responsible for all the sophisticated stuff like auto-wiring.
And these BeanPostProcessors are incredibly powerful. I want you to picture them as inspectors on the assembly line who get to examine every single bean that comes through. They have the power to check things, modify the bean, or even swap it out for a completely different version before it's finished.
So these inspectors get 2 chances to jump in. The before initialization method runs right after the dependencies are injected, but before your own custom setup code runs. Then the after initialization method runs once the bean is totally configured, and this is where a lot of Spring's most powerful features, like proxies, come into play.
So remember our question about how @annotated works? Well, here's your answer. It's not magic. It's a specific post processor called the auto-annotated BeanPostProcessor. Its entire job is to scan every bean for that @autowired annotation.
and then inject the correct dependency. Simple as that. But postprocessors do way more. For advanced features like @transactional, they do something really clever. They don't give you back your original bean. Instead, they wrap it in a proxy object to add that extra transactional behavior.
This proxy basically sits in front of your real object and adds behavior around its methods, like starting a transaction before a method is called and committing it after. This is a core concept in something called aspect-oriented programming. Now, Spring is smart. It has two ways to create these proxies. If your class uses an interface, it uses the standard proxy tool that comes with Java. But if your class doesn't have an interface, it uses a powerful third-party library called CGLIB to create one on the fly.
Whew, okay. Let's take a step back and do a quick recap of our factory tour. Let's follow the entire journey of a Spring Bean, from just an idea to a fully working product.
So, it all starts with a scan to find your classes and create those blueprints. Then, the bean hits the assembly line and gets created. Dependencies are injected, then our specialist inspectors, the BeanPostProcessors, do their work, handling things like @AutoWired and maybe even wrapping the bean in a proxy. After all of that, your custom initialization code runs, and that's it. The final fully configured bean is ready to go.
So why does any of this matter? Because once you understand this flow, the magic of Spring disappears. It becomes a clear, logical, and really powerful process. And knowing what's happening under the hood is what takes you from just using Spring to truly mastering it. It helps you debug tough problems and unlock the framework's full potential.
So now that you've seen behind the curtain, now that you know the magic, how is this going to change the way you write your code? I hope this tour gives you a brand new perspective on the framework you use every day. Thanks for watching.